So we are going to start with the second law of thermodynamics. Okay, so basic idea क्या है भाई second law में कि first of all when we read the production, right, we read the production में जैसा पढ़ा था, similarly you need to study the thermodynamics from now itself. Okay, so production में कैसा पढ़ा था generally metal forming में, कौन सा स्टार्ट था वो शीट मेटल ऑपरेशंस, राइट. शीट मेटल ऑपरेशंस कैसा पढ़ा था, रिविजन्स भी कैसा करा था, सिमिलरली आर गोइंग टू स्टडी हियर. ओके, so first of all now I will start like this. Okay, what is why second law, what is first law actually. First law during a process of the cycle energy is conserved, ये था स्टेटमेंट फर्स्ट लॉ का. ओके, फर्स्ट लॉ was based upon the law of conservation of energy. Energy neither be created nor be destroyed, but it can be converted into one form to the another form. Okay, that was the statement of the first law. Okay, so where the first law fails, first of all, first law never fails. Okay, first law never fails. It is a law. Okay, it is universally accepted. What is law? Law is universally accepted without proof. Okay, so what about the direction, feasibility and quality? It doesn't, first law is not concerned about the direction, quality and feasibility. That law is independent. Okay, it does not depend upon anything. Okay, it itself tells something, that energy, law of conservation of energy was the criteria of the first law. Okay, so for example in बोला था कि डॉक्टर है, डॉक्टर when I tell the doctor to check the bike, he will not check. Okay, when I tell the engineer to do the operation, he will not do. Okay, so डॉक्टर का रोल अलग है, इंजीनियर का रोल अलग है. सिमिलरली फर्स्ट लॉ का रोल अलग है, सेकंड लॉ का रोल अलग है. ओके, सो इट इज़ नॉट द टास्क ऑफ द फर्स्ट लॉ, डायरेक्शन, फिजिबिलिटी, क्वालिटी बताना. तो अब सेकंड लॉ क्यों, वाई सेकंड लॉ? सेकंड लॉ गिव्स द criteria of the feasibility of the system, whether the system is possible or not. Okay, possible or not. So and it also gives the direction with the help of the entropy. Okay, it is also known as directional law. इसके ऊपर कुछ एक्सप्लेनेशन नहीं दिया, बट यू कैन अंडरस्टैंड. ओके, सो ऑल द स्पॉन्टेनियस प्रोसेस इन द नेचर, वो डायरेक्शन देता. ऑल द स्पॉन्टेनियस प्रोसेस इन द नेचर अकर्स इन वन डायरेक्शन. ओके, फ्रॉम हाई पोटेंशियल टू लो पोटेंशियल. जनरली एनर्जी जब भी ये होती है फ्रॉम हाई टेम्परेचर टू लो टेम्परेचर, high potential to low potential, the process will take place in only one direction. Okay, so this is given by the second law. So to study more about the second law we'll study. But next concept is thermal reservoir. What is thermal reservoir? Body or the system which has infinite heat capacity is known as thermal reservoir. Okay, so suppose for example dQ will be equal to mc dt, right? So mc is the heat capacity, m is the mass, c is the specific heat, right? So if we took mc is actually the heat capacities. Okay, so thermal reservoir, it is a body of the system which has infinite heat capacity. उसमें क्या है, इन्फाइनाइट हीट कैपेसिटी होती है, राइट. ओके, सपोज फॉर एग्जांपल सी इज डी क्यू बाई टी, राइट. इफ आई वांट टू चेंज द टेम्परेचर टू 1 डिग्री, सी इज एक्चुअली स्पेसिफिक हीट कैपेसिटी कितनी है रिजर्वायर की, इन्फाइनाइट है. सो आई कांट चेंज, इफ आई वांट टू चेंज 1 डिग्री टेम्परेचर, so if I need to supply the infinite heat capacity, infinite heat I need to supply. Okay, so I can't change the heat, I can't change the temperature of the reservoir. If I do not change the temperature of reservoir, that is known as thermal reservoir. Thermal reservoir is a reservoir which has infinite heat capacity. समझ में आया कि सपोज फॉर एग्जांपल एक मेरे पास एक बॉडी है, अगर से मैं उसकी टेम्परेचर चेंज करना है, अगर से मैं टेम्परेचर चेंज कर लिया तो मैं उसको थर्मल रिजर्वायर नहीं बोल सकता. थर्मल रिजर्वायर कब बोल सकते हैं, जब उसके टेम्परेचर 1 डिग्री भी चेंज करने, आई नीड टू सप्लाई द इन्फाइनाइट हीट. ओके, reservoir with infinite heat capacity is known as thermal reservoir. So this is the concept of thermal reservoir. So we studied through thermal reservoir. Okay, so next we are going to discuss about the source and the sink. What is source actually? Source is a reservoir which supplies any amount of heat, okay, without undergoing a temperature change. Example, sun. So यहाँ से if you look from the other angle, we can say that sun है. If you want to extract if I extract the energy, any amount of energy from the sun, then the sun का temperature decrease होता नहीं होता. Okay, so source is a reservoir which supplies an amount of heat, any amount of heat without undergoing the temperature change. Okay, so what about sink? Sink can absorb any amount of heat without going a temperature change. Okay, suppose for example river, lake, etc. These are the reservoirs. Okay, these are the reservoirs, thermal energy reservoirs. Okay, other than this reservoir, suppose for example a copper bar at 100 degrees centigrade, is it a thermal reservoir? No. If I extract the heat, then the copper bar will cool. Okay, that is not thermal reservoir. Okay, Next, actually in steps for analyzing बोला था सर कि how we are going to analyze the things. For suppose for example for first law we analyze, we develop the first cycle. First law was for the cycle, right? So we develop the first law for the process by using a mathematical technique. If we use that technique, we get new term, that is we get to know about the internal energy property. Okay, similarly we are going to derive the second law. Okay, second law for the cycle. So by using the mathematical technique, we are going to define the entropy. Okay, new property, we are going to discover the new property, that is entropy. Okay, so the analysis part is same. Okay. Okay, but here in the second law of thermodynamics, we are going to discuss only about the cycles. Okay, we are not going to discuss about the process. We are going to discuss only about the cycle, like refrigeration cycle, heat engine cycle, etc etc. Okay, राइट. सो उसके बाद क्या बोला कि जनरली दे आर फोर इंपॉर्टेंट फॉर्मूलेस, इंटीग्रल ऑफ पी डी वी, डी क्यू इक्वल टू डी यू प्लस डी डब्ल्यू जैसे पी. ओके, एंड फोर्थ formula we are going to discover here. Okay, so we must know these formulas and we must know the supporting formulas. Okay, these are the important, very important, very important places we need to focus. Okay, ये बोला. उसके बाद we are going to discuss about the second law of thermodynamics. Second law of thermodynamics for a cycle. Okay, so statement is, according to Joule conducted experiment, according to him, the complete work can be completely converted into heat, but complete conversion of work is heat into work is not possible. Okay, work is high grade energy or low grade energy. Work is high grade energy, heat is low grade energy, so we can't convert low grade energy to high grade energy, but we can completely convert high grade energy into low grade energy for a cycle. Okay, for a process it is not, for a process it is possible, for a cycle it is not possible. Like for example, how for a process it is possible, give me the examples. So first of all, if you take isothermal process, if we talk about isothermal process, dq equal to dw. Yeah, so dq, total amount of heat, is converted into work for process. Similarly for polytropic process, dq is less when compared to dw. If you talk about adiabatic process, dq is 0 here when compared to dw. Okay, this is adiabatic process. Okay, so for process it is possible, but for cycle it is not possible. So actually हुआ क्या कि Joule could not give any significance. What the statement Joule said? Joule said work can be completely converted into heat, but complete conversion of low grade energy into high grade energy is not possible. Okay, for a cycle, so he cannot give the proper significance. So Kelvin came and gave the statement that it is possible to construct a device which produces work continuously while exchanging heat from a single reservoir. That means according to Kelvin, he indirectly is telling the statement of the Joule. Okay, so statements are different, but we cannot give the law of the Kelvin, statement of the Kelvin, that is the law of thermodynamics, right? So statement is same. So what is the significance of the Kelvin? What is Kelvin is saying? So generally he is telling that it is impossible to construct a device. Suppose for example, if a device is there, the device is continuously producing work. So to continuously produce the work, the device must run in the cycle, right, from the end to end points. So that is producing work continuously, and it is exchanging heat from a single reservoir. Okay, so this complete conversion is not possible according to first law. Suppose for example, if you write, if you take the engine or that device as a system, then you can see that total heat is converted. Total heat can't be converted into work. Okay, if you write the first law for that cycle, so the heat must get rejected, right? So it must work under two reservoirs. So similarly, uh, he gave the same significance. Okay, he gave the significance, right? Like with one reservoir it is not possible to convert complete heat into work, but more than one reservoir it is possible. With more than one reservoir it is possible. Okay, so if you take the device which which violates the second law is known as PMM2, virtual motion machine 2. Okay, so it violates the second law. So efficiency of the PMM2 is 100% because total heat is converted into work, and it is it is continuously producing work with exchanging heat from the single heat reservoir. Okay, so that is PMM2. So I think you have understood here, but one thing I didn't understood, that how we apply the first law. According to first law for the cycle, summation of Q will be equal to summation of W. So first law is valid, right? So why, for why it violates the first law? PM2, why it violates the second law, but why we can't produce the work? That is my question. So my doubt was कि generally अगर से वो PMM2 को लिए, so if we consider that PMM2 device as our system, then if we apply the first law summation of Q equal to W, यहाँ पे summation of Q totally completed into work हो रहा ना, तो how can we say that it is violating the second law and first law? मेरा डाउट ये था. तो एक्चुअली देखा गया तो समीशन ऑफ क्यू इक्वल टू डब्ल्यू राइट है, बट इसके आगे भी एक स्टोरी है कि देर इज़ ओनली वन इनपुट, वन क्यू एंड वन डब्ल्यू. सो इट इज़ नॉट पॉसिबल. इट वायलेट्स द फर्स्ट लॉ. फर्स्ट ऑफ ऑल फर्स्ट लॉ में it should there should must be input and output, there must be input and output, okay, but here it is only input, there is no output. So we cannot say that an engine will extract the heat and completely continuously produce the work from interacting with single reservoir, okay. So this is not possible. It violates the first law and it also violates the second law. All right, second law क्या बोलता कि it is not possible to construct a device which produce work continuously, but ये work continuously produce कर रहा है, इसलिए it is violating second law. Violating first law. फर्स्ट लॉ को कैसा वायलेट करता है? एक इनपुट है और आउटपुट नहीं है, एक इनपुट है आउटपुट नहीं है, तो आउटपुट नहीं रहा तो हाउ इट इज़ पॉसिबल? दैट इज़ द थिंग. ओके, सो नेक्स्ट वी आर गोइंग टू स्टडी अबाउट द concept of heat engine, okay, and PMM2 is not possible because efficiency can't be 100%, okay. So heat engine, what heat engine does, it takes the heat from the source, high temperature source, and it partially converts the heat and it rejects it to the sink, okay. So actually we are satisfying Kelvin की बात मान रहे अपन, okay. So what Kelvin said that we it is not possible to continuously produce work while exchanging heat from a single source reservoir, okay. So we are केल्विन की बात मान रहे हैं. केल्विन की बात मान के क्या करते हैं अपन? टू रिजर्वायर्स कर रहे हैं, ओके. Okay, so we are extracting heat from the source and we are rejecting it to the sink, and partial we are converting. So if you apply first law, Qn minus Qr equal to W, okay. So if Qr is W, then Qin will be equal to W. It violates the first law, also it violates the second law because efficiency can't be 100%, okay. So this is valid for reversible process always as well as irreversible process, okay. So this is the for second law for the heat engine, efficiency formula for the heat engine. Next, Clausius statement. Without any external energy input, it is impossible to impossible run the system in a cycle which extracts the heat from the lower temperature and it rejects it to the higher temperature, okay. It is impossible without any external energy device, okay, without any external heat input, it is impossible, okay. So it is impossible. Suppose for example if it is possible, then QL, we are extracting QL, right? So QL will be positive and minus QH, we are rejecting it to the source, so minus QH will be equal to 0, so QL will be equal to QH. So QL will be equal to QH, which is not possible. It violates the first law. According to first law, the temperature which the highest according to first law, the heat at high temperature has greater significance when compared to heat at lower temperature, okay. So generally if we look at the atmosphere, there is a lot of energy is there, okay. We cannot utilize the energy because the temperature is low, okay. If we take the reference as our atmosphere, then atmospheric temperature, the heat is at atmospheric temperature, right? So we cannot extract the heat, alright. So it is a dead form of energy. So generally if you look at the equation, QL minus QH equal to 0, QL which is at low temperature is also known as low grade energy because it is at low temperature, okay. So QH is at high grade energy. So if we want to extract it from the low grade energy, if we want to reject it to the high grade energy, it is not possible, okay. It is not possible without any external heat input, okay. So according to Clausius, if we give the external heat input, it is possible. According to Clausius, if we give the external heat input, it is possible. Now if you write the first law for this, QL minus QH equal to minus W, okay. Then W will be equal to QH minus QL, which is same as the heat engine, okay. Now if while calculating efficiency, here in the refrigerator there is no efficiency, instead there is COP, okay, coefficient of performance. So coefficient of performance is known as desired effect by refrigeration effect or desired effect by W input. Okay, so actually why we are using the refrigerator? Refrigerator is a device which is used to create and maintain the temperature which is less than the atmospheric temperature. Okay, refrigerator we are using, air conditioning we are using, what we are doing, we are maintaining the temperature of the room lower than the atmospheric temperature. Refrigerator in the sense it is not only the fridge. Okay, it is also in AC, you can say it is also an AC. So room temperature maintain कर रहे अपन. Okay, so we are extracting the heat from the room and we are ejecting into the atmosphere. Okay, so by using the external device, that is the compressor. Okay, that is the thing. So what is the refrigeration effect? Actually, refrigerating effect is the amount of heat which is need to be extracted from the storage space in order to maintain it uh, maintain it at lower temperature. Okay, that is the refrigeration effect. Now COP will be equal to refrigeration effect by W input. Now we are that is the amount of heat which is need to be extracted from the storage space, right? How much heat we are extracting? That is, we are extracting QL. So QL, refrigeration effect, UL by W input, that is QH minus QL. Okay, this is the formula for the COP. Okay, this is the concept of COP, desired effect by work input. I think you understood each and everything, okay, about the refrigeration effect and the refrigerator. Okay, refrigeration effect is the sense we are the amount of heat which is need to be extracted, that is the QL amount of heat we are extracting in order to maintain the storage space at lower temperature. What is refrigerator? Refrigerator is a device which is used to maintain the temperature which is lower than the atmospheric temperature. Okay, that is the refrigerator. Okay, so up to refrigerator it was good, but heat pump में थोड़ा confusion है. Okay, so actually these cycles are reversible cycles, the anti-clockwise cycles, because they are work consuming cycles. So what is heat pump? Actually, heat pump is a device which is maintaining temperature higher than the surroundings. ठीक है, मेंटेनिंग टेम्परेचर हायर देन द सराउंडिंग्स. तो होता क्या, एक डाउट था कि क्यू एल से कहीं को एक्सट्रैक्ट कर रहे हीट. जैसा कि फॉर एग्जांपल क्यू एल से कहीं को एक्सट्रैक्ट कर रहे हीट. ठीक है, क्यू एल रूम से कहीं को एक्सट्रैक्ट कर रहे हीट, रूम से एक्सट्रैक्ट करके बाहर कहीं को डाल रहे. दिस वाज मिसकन्वीनियंस. ओके, रूम से एक्सट्रैक्ट करके बाहर नहीं डाल रहे अपन, बाहर का टेम्परेचर कम है, that becomes your source. Okay, where you are standing in the hot source now. रेफ्रिजरेटर में तुम ठहर रहे थे सिंक के पास, नाउ यू आर ठहर रहे सोर्स के पास. ओके, नाउ योर सोर्स, यू आर एक्सट्रैक्टिंग हीट फ्रॉम द सराउंडिंग्स. ओके, जैसा कि फॉर एग्जांपल टू मेंटेन 25 डिग्री, आउटर इज़ 5 डिग्री, बाहर से ही एक्सट्रैक्ट कर रहे, अंदर से एक्सट्रैक्ट नहीं करके बाहर नहीं डाल रहे, बाहर से ही एक्सट्रैक्ट कर रहे. You think you thought that you are extracting from room. No, you are not extracting from room. बाहर से extract करके अंदर डाल रहे हो. Okay, that is the thing there. That's why we are using external device, external work input, right? So actually temperature अगर से heat transfer high temperature से lower temperature पे हुआ तो temperature high temperature से low temperature हुआ तो फिर device use करने की क्या ज़रूरत है? extra device और प्रोड्यूसिंग डिवाइस बनता था, एक्स्ट्रा डिवाइस एक्स्ट्रा वर्क इनपुट यूज़ करने की क्या ज़रूरत है. दैट इज़ द थिंग. ओके, दैट इज़ द मेन डिफरेंस बिटवीन द हीट पंप एंड रेफ्रिजरेटर. एक्चुअली मैं पॉज स्टार्ट ही नहीं कर रहा. ठीक है, आई नीड टू डिस्कस. ओके, वी डिस्कस स्टिल हीट पंप. ओके, now we are going to discuss about the Carnot cycle. So who is the Carnot? Carnot is the father of thermodynamics. Okay, he has given the large contribution. Okay, Kelvin, Joule and all they gave contribution, but Carnot's contribution is very very more. Okay, he published the book which is Reflection of Motive Powers on the Fan. Okay, so at the age of 32 he died. Okay, so he was working on the combustion system. Okay, he gave mathematical equations and he gave the various steps of diagrams. Okay, curve diagrams. Okay, so after that Rankine came, and Rankine generally took those equations and gave the significance of those equations, the four processes. Okay, first process is reversible adiabatic compression process. Next, reversible adiabatic isothermal expansion process, reversible adiabatic expansion process, then isothermal compression process. Okay, these are the four processes. Okay, if the isothermal expansion, you need to add the heat. Okay, heat is added in the isothermal expansion process, heat is rejected in the isothermal compression process. Okay, these are the four cycles of the Carnot. Okay, So as you look, one question arises that why this cycle is not possible. So one student tells that processes are generally uh, reversible. So if we talk about the auto cycle, if we look at the auto cycle, then the process is reversible. Then one engine is approaching the reversible. It has a reversible, but then that is not the case. The case is that there are two fast processes and there are two slow processes. Okay. So if you take the finger, if you take the flame, if we if you move the finger very fast over the flame, then what happens, sir? Generally, the heat, you will not feel the heat. Why? Because that process is automatic. Now, if you take, if you rub your hand slowly, then temperature will not increase because work is not converted into heat. You are giving work, but that is not converted into heat because process is very slow. That is isothermal process. Next, if you rub very fast, then the process is very more. Then the process is generally the temperature will increase. Okay, one is fast, one is slow, one is fast, one is slow. So this is the case, right? So for this case, you will not use. So that's why the Carnot disturbance hai. Therefore, the Carnot theorem is not used. Okay, Carnot cycle is not practically implemented. Okay. Suppose for example, so that's why the Carnot told the crucial maintenance of Carnot if many cycles are working between the two temperature limits, then the cycle which has reversible cycle which has the more efficient when compared to the other two cycles. Suppose for example, three cycles are working in between the two temperature limits. Okay, if one is reversible, other are two reversible, then cycle A has more efficiency than the other two. Okay, this was the one statement. And the next statement is, suppose for example, if three cycles are there, okay, two are reversible and one is working in air as a working fluid and helium as a working fluid. Now tell me which has the greater efficiency. So these two reversible cycle has a greater efficiency. Look, the contribution of fluid, this is a minor factor, okay, in the efficiency when compared to temperature. Okay, when compared to major factor is temperature. Actually, that is told by Carnot. Okay, the efficiency of reversible cycle does not depend upon the type of fluid. It only depends upon the working temperature. Okay, it only depends upon the working temperature. That is told by the Carnot actually. Okay, so before in we go into the history, the people were working in the with the help of the different fluids and all. They are not focusing on the temperature. Okay, so if we like now you can see that we are going to use a compressor. Okay, previously people didn't use the compressor. We are extracting work from the we are producing work, right? So they thought that why we must invest, why we must give the work. Okay, again the Carnot, according to Carnot, if we must for the compressor we add work, but we increase the temperature of the fluid. If we increase the temperature of the fluid, then if we if we expand that fluid, we will get a more amount of work. Okay, we indirectly we increase the efficiency of the engine. Okay, so if we compress, then the temperature, if we increase, if we use that heat at higher temperature as an input, then the efficiency of the cycle is going to increase. This was elaborated by the Carnot. Okay, this is told by the Carnot. Okay, this is the thing. This was about the Carnot cycle. So one thing I missed in the Carnot is that, okay, sir, actually, according to first law, efficiency uh, efficiency can't be one, efficiency can't be infinity. Okay, efficiency can't be one, efficiency can't be infinity. Wait a second. So one point I need to discuss is that, okay, generally according to first law, efficiency can't be 0, can't be 1, can't be infinity. So what is right here? So according to first law, efficiency can't be infinity. According to first law, according to second law, efficiency can't be 1. Okay, first law, efficiency cannot be infinity, and according to second law, efficiency can't be 1. Okay, if the efficiency is 1, for example, then what happens? Then W will be equal to Q input, right? Efficiency can't be 1, efficiency can't be infinity. हमें एफिशिएंसी कांट भी 100%, अगर से एफिशिएंसी 100% है बोले तो wait, let me check. Okay, then heat rejection is 0, right? Which we discussed before. And efficiency 1, Q rejection 0 रहता. Okay, so according to first law efficiency can't be infinity. Efficiency infinity होने के लिए condition क्या है कि W by Q input, right? Q input will be W will be 0. Sorry, Q input will be 0. If Q input is 0, then and that means that is PMM1, perpetual motion machine. Okay, violation of the first law. Okay, without any heat input, we are producing, we are producing continuously, we are producing the output, that is PMM1. Okay, PMM1 violates the first law. According to first law efficiency can't be infinity. Okay, according to first law efficiency can't be infinity. So what about work input? Work input will be infinity in first and PMM1. Okay, so in second law, if you want to talk about the second law, according to second law efficiency can't be 1. The condition for the efficiency to be 1 is Q rejection must be 0. Okay, Q rejection must be 0. And also if we talk about the heat pump में क्या था सर कि QL by W input 1 by infinity, right? 1 by 0 आ रहा COP infinity आ रहा. Okay, so it can't be, COP can't be infinity. Okay, it violates first law also, it violates the first law also, it violates the second law. वो उसका आंसर था. Okay, so that is the thing. Okay, now we are going to discuss about the temperature scales. Okay, we are going to discuss about the temperature scales. After that we are going to discuss the most important thing, that is Clausius inequality. So after Carnot के बाद generally Carnot क्या बोला था कि temperatures, it depends upon the temperature, major factor is temperature, but he did not comment about the he नहीं बोला था कि minor contribution रहता working fluid का. Okay, so so which temperature scale actually, temperature की बात करें तो कौन सा टेम्परेचर स्केल, कौन सा टेम्परेचर की बात कर रहा है एक्चुअली देखा गया था when two scales meet at steam point and ice point, at the intermediate point it depends upon the fluid. Okay, when it depends upon the fluid, it means that temperature depends upon the fluid, it means that it depends upon efficiency depends upon the working fluid. Okay, if temperature depends upon the working fluid, then also efficiency depends upon the working fluid. कि कार्नोट कौन से स्केल की बात कर रहा, उसके लिए है ना केल्विन वर्क करा. सो ही वर्कड फॉर दैट थिंग and he developed the new scale which is independent of working fluid. Okay, which only depends upon the temperature. So generally arrangements को ऐसा रहता कि generally two engines are coupled. Okay, two engines are coupled and one engine. So efficiency 1 लेके थोड़ा manipulations कराओगे. Q by QH will be a function of TH by T, and also QL by Q is a function of T and T2. Okay, and also efficient engine जो असली इंजन है उसका that is QL by QH is a function of TL by TH. Okay, that is the thing. So actually he proved that QL by QH will be equal to TL by TH. Okay, ये result ले तो काफ़ी है. That is the thing. Okay, QL by QH equal to TL by TH. Alright, so ये था generally. So with the help of this we are going to discuss the Clausius inequality. Clausius inequality, cyclic integral of dq by t is less than or must be less than or equal to 0. This is the most important thing. This is the second law of thermodynamics for the cycle. Okay, so first of all, if we take the heat engine, if we discuss about the heat engine, if we take the reversible heat engine, then if we talk about the efficiency is 1 minus QL by QH, right, equal to 1 minus TL by TH. यहाँ से अपन क्या कर सकते हैं, QH by TH minus TL by QL by TL equal to 0. Cyclic integral of dq by t must be is equal to 0. ओके, ये है रिवर्सिबल साइकिल का कंडीशन. इफ साइक्लिक इंटीग्रल ऑफ डी क्यू बाई टी इज इक्वल टू जीरो, देन वी कैन से दैट साइकिल इज रिवर्सिबल. Okay, so 1 minus TL by TH, this is valid for only reversible process. Okay, 1 minus cycling around dq by t is only valid for a reversible process. Because we are talking about the reversible process. So next irreversible के लिए क्या है? First of one of the most condition is that important condition है that efficiency of irreversible cycle is less than the efficiency of reversible cycle, right? So उसके लिए अपन फिर manipulation करके we come to know that cyclic integral of dq by t is less than zero for irreversible cycle. Okay, so from here two conditions: for reversible dq by t is less than equal to 0, and for irreversible less than 0. But what about is if the cyclic integral of dq by t is greater than 0? Cyclic integral of dq by t is greater than 0, इसका मतलब क्या है कि cycle is not possible. Okay, so reversible refrigerator के भी लिए अपन इक्वेशन बनाए, रिवर्सिबल हीट इंजन के भी इक्वेशन बनाए, और एक इक्वेशन बनाए, दैट इज COP of heat pump minus COP of refrigerator is equal to 1. But one condition is that they must be in the same temperature limits. ओके, सो क्लास वाइज इनइक्वालिटी का सबसे पहला एप्लीकेशन यहाँ देखते हैं कि इट टेल्स यू वेदर द सिस्टम इज साइकिल इज पॉसिबल और नॉट. सपोज फॉर एग्जांपल, TL is 5, TH is 500, TL is 300, okay, QH is 10 or QL is 2, or we are producing the 8 kilojoule of work. So actually when you look at this cycle, it is not violating first law, also it is not violating the second law. Thus this cycle is possible. ये cycle possible है नहीं है, this tells you the second law. Okay, it does not violate the second law, नहीं बोल सकते. All right, it does not violate the second law, नहीं बोल सकते. So therefore what you can say कि generally you have to check for the second law. It does not violate the first law, but does it violate the second law? Does the second law allow this? Okay, so to check the cyclic integral of dq by t is just to find out. If you find out, first of all cyclic integral of dq by t निकालने के बाद देख कि generally it is coming as positive or negative. If it is coming as negative, then it will be less than 0, right? So then it is possible, irreversible. If it is coming as equal to 0, then the cycle is reversible. If it is coming as greater than 0, then this cycle is not possible. Okay, so this is the whole concept of Clausius inequality. Next we are going to discuss about the coupled engine. कपल्ड इंजन में क्या रहता है जनरली? सेम केस ऑफ व्हाट केल्विन डिड कि दो इंजन्स रहते हैं विच आर कनेक्टेड इन सीरीज एंड वन इंजन इज कनेक्टेड डायरेक्टली टू द रिजर्वायर. सो कपल्ड इंजन क्या बोलता है एक्चुअली, व्हाट इज द बेनिफिट, वी आर गोइंग टू डिस्कस. बट जनरली इफ W1 इक्वल टू W2 ऐसा देता क्वेश्चंस में, तो हाउ टू फाइंड आउट दिस थिंग्स. फर्स्ट ऑफ ऑल W1 विल बी इक्वल टू QH माइनस QL एंड W2 विल बी इक्वल टू कौन से दो लिमिट्स में काम कर रहा देख लेना, उसको कन्वर्ट करना. अगर से रिवर्सिबल है तो कॉमन टर्म्स को निकालना, उसको डिवाइड करना, एंड वी आर गोइंग टू गेट द रिलेशन बिटवीन द टेम्परेचर्स. ओके, डोंट नीड टू बटिफाई दिस थिंग्स. सिमिलरली W1 इक्वल टू 2W2, efficiency 1 is equal to efficiency 2, this thing. Okay, so what is the benefit, what is the use of the coupled engine, this we are going to discuss. Okay, so suppose for example नॉर्मल हीट इंजन जो कनेक्टेड था टू रिवर्स है, वो उसका क्या था, T3/T1. ओके, T3/T1 T3/T1 था. तो T3/T1 can be written as T3/T2, T2/T1. okay, so 1 minus efficiency, T3/T1 को ऐसा लिख सकते हैं 1 minus efficiency equal to 1 minus m2. After solving all this you will get efficiency will be equal to efficiency 1 plus efficiency 2 minus efficiency 1 efficiency 2. Suppose for example efficiency 1 is 0.3, efficiency 2 is 0.4, then overall efficiency will be 0.58. okay, this is the end result. okay, so यहाँ पे बेनिफिट क्या है, एडवांटेज क्या है, इसका यूज़ क्या है. सो सपोज फॉर एग्जांपल कि एक इंजन है, इफ़ यू वांट एफिशिएंसी एज 58, बट वी आर नॉट गेटिंग इंजन्स ऑफ दैट एफिशिएंसी, so we can couple the engines. okay, so if we got the engine 30% efficiency engine and one engine is 40% efficiency engine, if we couple them we will get 58% efficiency engine. So that is the concept of in coupling the engine. To increase the overall efficiency we are going to couple the engine. okay, this is the concept of coupling of the engine. okay, so ये था second law of thermodynamics. Last concept we will discuss. okay, after that second law is completed.
आफ्टर द कंप्लीशन ऑफ सेकंड लॉ अगेन वी विल रिवाइज द होल थिंग्स कि होल थिंग्स कंप्रेस करके कोरिलेट करके क्या क्या रिलेशन था, व्हाट वी लर्न, ओके एक्चुअली व्हाट आर द इक्वेशंस ऑफ रिवर्सिबल, व्हाट आर द इक्वेशंस ऑफ रिवर्सिबल साइकिल्स, व्हाट इज सेकंड लॉ, क्या है वो सब चीज़ें वी विल डिस्कस। ओके अगेन फर्स्ट लॉ के बारे में बात करें तो सर बोला इन्फिनिटी एफिशिएंसी, अगेन Q1 must not be equal to QL must not be equal to QH in terms of heat pool. Clausius statement, according to Clausius statement concept in the concept of reservoir, he told that QL must be not be equal to QH. Okay, if W is 0 then QL will be equal to QH. If QL is equal to QH then this violates the first law बोला था। So violation of the first law के बारे में डिस्कस करेंगे। फर्स्ट लॉ क्या क्या मतलब क्या क्या फर्स्ट लॉ क्या क्या बोलता, सेकंड लॉ क्या बोलता, व्हाट इज द सिग्निफिकेशन ऑफ सेकंड लॉ, where we can use the second law, where we can use the first law. Okay, these things we will discuss. Okay, these are the basics we will discuss. All right, ठीक है चलो। लास्ट थिंग वी विल लास्ट थिंग क्या है कि व्हाट इज हाउ टू इंक्रीज द एफिशिएंसी, दैट इज द थिंग। ओके, विल डिस्कस।